So after following transfer learning from zero to mastery TensorFlow, I wanted to apply it on a real life problem because data science is an experimental field. So you have to take that thing, apply to code, and see if you can reach end to end. And that's why Kaggle is so important because no matter the time, you will find there are always active competitions and which have monetary reward. And because of that, we can actually check always if our level of skill is up to date. So if you can't win any of these, you can practice on the old competitions, and that's why I wanted to practice the vision knowledge on some of the data sets. So I did this. Okay, image fish. I decided that I would do this fish classification. This had a decent amount, large size data, which is 2 GB. And in most of the data sets, in the if you are learning TensorFlow or Keras, and if you work on any data sets, you will find most data sets are less than 1 GB. Okay, the demo ones. And the image is so simple, and even you can't understand anything so quickly if it is just 28 or 32 pixels, right? So data sets which are, real life things and also in GBs, they are good candidates. So I thought, why not? Let's go for this. And even here, the images of fish were just five, six fishes like this. But after I downloaded the data, this was images captured from fishing boats where the fishes were being cut and gutted and the blood and this thing. So it was like I couldn't go forward. So I moved to this competition, which is a Chindi one. There it wasn't a paid competition, whereas when this was running, this was a paid competition. So would have been good, but didn't want to work on it. So dog breed classification, and this is again a good data set because images are real life thing. Okay, different kinds of dogs, you can see them, and most importantly you can understand them. Okay, dogs compared to cats, they have a huge variety in how they look. You can actually check this. So Alpenpincer, sorry for butchering the name because I'm not a dog person. So you see, one species of dog, all of them are similar, and interestingly, you will find we also have images like these where we can't identify where the dog is. It's also a person, and these are quite center cropped. We can easily identify the dog, but some of the images, it's kind of like difficult. You have a partial face, you have this thing. So we have good variety of different kinds of dogs. So even though this was a playground competition, so I decided to do this over the fish cutting one. So for this data set comes from Stanford Docs. This data set is taken from ImageNet dataset, and ImageNet dataset is the OG dataset. So this is still now. This started since 2007 6. This was a time when entire deep learning for images began. So this has a old legacy, and since then to even now, the data set is still relevant. Even though images are around 500 pixel by 500 pixel, this is one of the most comprehensive one, and we are taking its subset. So whether it is dog breed identification or it is food classification. So there is food 101 data set. Even this data set, I think, consists from images from like ImageNet. I don't think they are from ImageNet, but this dog breed classification is from ImageNet, which is the standard one. So still relevant, still important, but just the problem is simpler. So I took this. This you can find on TensorFlow as Stanford Docs. This is the dataset name. And then code for that is here. Okay. On my repository of TensorFlow certification one, the repository is dog breeds. So I simplified the code so that it was easy to read. Okay. So one line loading dataset. Simple one line, so then not much to remember. It is very easy to follow. So you get the data and then you check the data set. So I downloaded the data here, and then take is a TensorFlow function wherein we can actually check what does it have here. So you see data type is int 8. Shape is some image will be different, different images of different size, and it has three color channels. So if I take 10, it will show me 10. Oh, it doesn't show me 10. Okay. But if you want to check train data and underscore this thing, zeroth element of the training data, it gives you an error. So many such things. TensorFlow is different at from PyTorch. In PyTorch, I think this would have been fine because it tries to follow standard syntax for everything, whereas in TensorFlow, you kind of like need those things precisely. So it's better to, use minimum number of functions which you know well and master them well, so that there is no confusion when you move from TensorFlow to, let's say, PyTorch, because majority people use PyTorch and they will keep using it probably. I don't think TensorFlow can come back from this. Anyways, so choose minimum number of functions, write the code so that it is easy to read and you are good to go. Okay. So downloading data, pretty simple, first thing. Then getting the data into the shape we want. So we have tf.image.resize TensorFlow library. In that we have tf dot, and according to whatever the function we want, they are grouped accordingly. So here if I do resize, image is resized to the shape which I have chosen here, 224 by 224. Standard thing, like I said, 2000, since 2012 people have been using this size. Actually soon, in a year or two, I think we will start working on much bigger images, because our hardware will be faster, and even our models will be better. But right now this is good enough. So convert it to this, cast into float. If you wanted to use reshape, then it would have been reshaped to 2 to 4 comma 2 to 4 comma 3, something like that. But here we are just resizing the image, so the number of channels are not included. So easy to read, easy to understand, good to go. Okay. Then I'm processing it, just calling it as a map function, converting it into batch. So train data dot batch, and you give batch size. Pretty simple. And then here only training data we shuffle. Okay. If we shuffle test data, then the order of the things we are trying to test will be changed, and the submission order will be different, but the order shuffle chooses would have been different. So it might feel ki, oh, I also want to do shuffle here, but no, the thing I'm testing, I need that precise order because it is going to get checked. So common sense things we need. That's why easy to read code. So we do this, and this is how I have written the architecture. So yesterday for transfer learning, I hadn't, paid attention on how the model should be named. I tried it a bit better now. So custom model architecture was my class name. I chose to do it by extending the model. Why? Because we can debug it. We can use sequential, which is list sequence of layers one after another. Only simple models can be done that way. Or we can have one transformation layer after another as function. We can also do that. But again, its structure is not as easy to read as this one. So we see this, I can do initialization here, and then the forward pass is here, separate. So input shape, anything which is in full capital, these are important things. So I have done it like that. So input shape and number of classes I have defined. Accordingly, input layer is created of input shape. Okay. And then pre-trained model. If we wanted to initialize untrained model, then we would have defined that model. But here I'm using pre-trained model, capital, full capital, because easy to check. I set it as non-trainable, and then whatever is its output, I convert it into some smaller thing. So max polling global average 2D, I think here I would need to give what's the dimension I've actually wanted to get into. I can give that. And then fully connected layer and final activation layer, because I want to predict a number of classes which are this 120 in this case, dog breeds. So complete model is like this, sequential, and inside that I have input layer, which is this on pre-trained model, embedding, fully connected, activation, done. So simple model definition, easy to debug if you want. For example, if I put debug here, okay, and then I say debug cell, this should, when it is training, should allow me to pause and check every model instance one by one batch, how the training happens. Okay, it does not. Okay. Wow. Then there is no point here. That's weird. But okay, if it's fine. It's still easy to read. So this is how I simplified the code, made it succinct, easy to read, and I think it makes a lot more sense to me, even though this debugging thing didn't work the way I wanted it to. Maybe I'll put it in a different format. But going back to this thing, code is a lot more experimentation. So competition, choose any good competition, especially if the active one you can get a rank. But until then, you can practice on smaller ones. I wanted to get the code in standard format, and that's what I did. Simplify the code so that it is easy to read, easy to understand. If you want to check this code, go to my GitHub repository of TensorFlow in 7 weeks. And in that, you should find the code for this dog breed classification in this one vision. I have not yet uploaded, but I'll upload it right here, right now. So I didn't finish. I wrote the first draft of code. Then I'm gonna do iterations, do some transfer learning here, and try to get a decent leaderboard rank. And once that is done, then I'll try to choose and find a good image classification or maybe a even different competition. So this was me doing transfer learning for TensorFlow certificate on this Kaggle competition.